Alright, in this lesson we're going to talk about linear measure. If you actually want to measure something, it's got to be a finite length. In that first section we talked about lines, which would go on forever. Therefore those things would not be able to be measured because they keep going on forever. So the first thing we're going to talk about here is a line segment. Now a line segment we're actually going to be able to measure. I have a picture of a line segment here, down here from point A to point B. But what a line segment actually is, it's part of a line. So take that whole line and kind of cut off the two ends, and you're left with a little chunk inside of it, and that's going to be considered the line segment. Notice it has two endpoints here. In mine, it's point A and point B. Now, if we're going to label that line segment, like we labeled lines and points and planes, we have to have a way to do it. The way we're going to do that here is we're going to call it segment AB. That would be my first one. Or we could call it segment BA. The order in which you say it does not matter. Pick whatever point you want to go first and whatever one you want to go second, and then just write them down. And then notice there's a little segment bar above it in this case. When we talked about the line, it had little arrows on each end of that segment bar to distinguish between a line, and now we have a segment. And when you read it, you're just going to read it like you've been hearing me saying segment AB or segment BA. Sometimes you're going to notice that you're going to have these 2 points. Let me highlight them a little bit here so it's easier for you to see what I'm talking about. You have A and B right next to each other. Notice there's nothing above it. So you kind of start thinking, well, we're talking about point A and point B. But it's going to be a little different in this case. You see those 2 points right next to each other, nothing above it. It's going to talk about the measure of or the length of some segment. And in this case, whatever those points are, it's going to be segment AB. Now I have that written down here in equation format. You see the A and the B equals, and then what's underneath my little X, it just says these two things are the same thing. If you see AB next to each other, equals, just talking about the length of AB. So what I have to get in your head right now is anytime you see 2 letters, now it might be C and D because those would be the endpoints of segment CD, but it's talking about the length of that segment, length of the segment. So in this case, my one little example here, I have this segment. Notice I've told you that it's 23 feet long. So that down here in the blue, I can write a mathematical sentence that if I read the words, it would say segment AB equals 23 feet. Now I want to look at this one and I want to know, well, what's the length of this segment? I have my ruler here. We're going to say this ruler is in terms of inches. I'm going to put my ruler on my segment. So I get it on there like that. Now I can look at this, and when I get to figuring out it's 2 inches, and then, well, it almost gets to 3/4 of an inch more, but it's kind of on that that next tick back, which would be your 11/16. So you're trying to figure out, well, do I call this 2 3/4 or do I call it 2 11/16? Now what you want to do is you're basically going to determine, well, which one is it closest to? Is it closest to the 2 11/16, or is it closest to the 2 3/4? So in this case, I can pull out my magic pen and it's going to blow this up. And you can see that I'm going to say that the end of the dot is the end of the segment. And when you look at it, you're noticing that it's closer to the 3/4 mark than it is to the 11/16. So in this case, I'm going to call this segment my segment AB. I'm going to write it. Segment AB is going to equal 2 3/4 inches long. Now say, don't worry about the left side of my ruler, but say that it would have come, and I would have had it to the end, and it would have been more like that. Now if that would have happened, going back to blowing this up, now you can see that it's closer to the 11/16. If that would have been the scenario, then I would have said my segment is 2 11/16 long. So just figure out which one is it closest to, and that's the one that's going to determine how long you say the segment is. Now, vocab word for today, other than line segment, now we have between. What does it mean to be between? And in the past, when I've asked this question, when I had a bunch of students, I found out that it's really hard to define the word between. Everybody always wants to say, well, it's between. Something is between it, if it's between. Well, it's hard to use the word between to define the word between. Now in math, we have kind of basically two scenarios. Notice it's talking about point B is between point A and point C if and only if. So we have these two things that are going to have to take place. Number one, you have to have 3 points and they have to be collinear. Thinking back to the other day, that means that they all have to be on the same line. And then part two, we have a little equation in here. Now notice, thinking back to what we just learned, we're going to have segment AB, or excuse me, I should say that right, the length of segment AB plus the length of segment BC equals the length of segment AC. So really, step two is dealing with numbers. When you talk about the length of segments, it's a number. It's maybe 2 inches plus 3 inches equals 5 inches. So as long as A, B, and C are collinear and this little equation holds up, then I know, in my case, I have point B is going to be between point A and point C. The picture, everybody's going to look at that and say, yeah, B is between point A and point C. Now I have a couple examples here, but I'm not going to do those now. Look at the next video and you'll be able to see those. So I want to talk about what it means to be congruent. This is going to be a very powerful word for the rest of the trimester and the rest of geometry. Now, congruent is not dealing with just equal. A lot of times people think equal, but kind of the simple definition that I've come up with here is same size, or excuse me, same shape and same size. So I'm comparing two different figures, and as long as they're the same shape and they're the same size, and size a lot of times is going to deal with the measure, as you see here, then I can say they're congruent. Notice the little symbol. This little symbol is going to be used a lot. I don't write out the word congruent very often. I'm just going to use, looks like an equal sign with a, I call it a squiggle on top. But now, if we get down here to this kind of the little examples here, are the segments congruent? I'm looking at segment AB on the left and segment CD on the right. Are they congruent? Well, I go through my two little checks basically. Are they the same shape? Well, they're both segments, so yes. Now I don't care if one's 5 inches long and one's 50 inches long. If you were just checking to see if they're the same shape, they would be. But in this case, segment AB, segment CD, same shape. Are they the same size? Well, I notice here that segment AB is 5 inches, segment CD is 5 inches, so yeah, I'd call it the same size. They're equal in measure. So then, yes, in fact, segment AB and segment CD are congruent. This is our little math kind of equation, if you want to call it, that shortens it up. Instead of having to actually write out segment AB is congruent to segment CD, we can put that in a little compact version here using our symbols. The other thing to notice that just showed up, I have what I call a little tick mark there and a little tick mark there. That's the way to show that segments are congruent, because if you just see two segments on a piece of paper and those two little tick marks aren't there, then you can't say they're congruent, even if they look that way. Now sometimes you're going to see two tick marks. Now you know that those two segments are congruent. Versus maybe there's another set of segments on the paper. One set of segments has one tick on it, the other set has two ticks. Then you can say that I have two sets of congruent segments, but they're not all congruent. And my next example would be here. Are these two segments congruent? Well, obviously first check their segments, they're congruent. Now the next thing is are they equal in length? Now think back to the don't believe your eyes slide, because we can't always go by that. Now, do they look congruent? I would definitely agree. They both look congruent. But can we say they're congruent? No, we cannot, because there's not enough information there. There's nothing on there that says they're both 5 inches long. They don't have the tick marks on them, so just not enough information to say they're congruent. And in most cases, we're going to assume that they're not congruent. Don't worry about that. That's something different. So that's the end of lesson 1-2.